Hi everyone, this is Deekshit. Welcome to my channel. In this particular video, we will going to discuss about automating secret rotation by using Lambda functions. Prerequisite to watch this particular video, you need to know the basics of AWS and Python. Especially in AWS, you need to know the services like Secret Manager, Lambda functions, EC2, and few other networking components in AWS. And before moving ahead, I have a small request. So this is a screenshot that I've taken from my YouTube analytics. I can see that 75% of my viewers have not subscribed to my channel. If you consider subscribing it to my channel, so then it will definitely motivate me to do more and more videos like this. So now without wasting any time, let's get started. I would say this video is continuation of one of my previous video where I've discussed about issues related to credential feature in Jenkins, where issues are reading and verifying actual values of credential. It's very difficult with the credential feature in Jenkins. And how do we protect from the deletion of the secret? So if someone accidentally deletes it, would we be able to kind of recover it back in the Jenkins credentials? The answer is no. And also restoring the previous values. Somebody, if accidentally updates the existing secrets with the wrong values, do we be able to kind of get the previous values and update it back? So with the Jenkins credentials, it is not possible. And the last one is rotating the secrets without human intervention. This is also very, very important because many projects or clients will have expiry for tokens or passwords. So in this case, before that particular expiry, we need to rotate that particular tokens and passwords. If we don't do it, so then the token will be invalid and all the pipelines or microservices which are accessing that particular credentials will gonna fail. So that's where to solve this particular problems, in my previous video, I've discussed about storing the credentials of Jenkins in AWS Secret Manager and installing the plugin on Jenkins through which like we can retrieve the values from AWS Secret Manager. So in that particular video, I've shown installing the plugin and how do we store the secrets in Secret Manager and then retrieving it out to Jenkins. But however, I didn't discuss about rotating the secrets without human intervention. So that is what we will be concentrating on this particular video. We will gonna automate rotating of the secrets which are there in the Secret Manager. I've already logged into my AWS account. So in this particular demo, we will gonna use a lot of services like EC2, Secret Manager, databases, Lambda functions, CloudWatch, IAM service to create rules and assign it to few of the services. So we're gonna use many other services as well. The first one is the AWS Secret Manager. You can see that I've already created two secrets where in one of the secret, I'm storing DB admin password. So let's assume that particular password is being used in Jenkins to execute few pipelines and as well as it is used by microservices to do some database operations. And the other secret, so which is GitLab Py token, let's assume this token, whatever it is stored here, is used by Jenkins to clone and to execute few of the APIs related to GitLab. So that's the reason the secret is there, is the assumption. And we will gonna enable a Lambda function for these two secrets to automatically rotate the values which are being there inside these particular secrets. And for this, so first what we will do is let's take the values which are there in the secrets and we will gonna test it whether they're valid or not. The first one is app DB admin. So I have already created a database. So I'm gonna provide the steps. How do we create this particular database in AWS? So that is a AWS documentation. I'm gonna provide it in video's description. So and command to connect to this particular database, I have also documented that particular commands in this repository. I'm going to provide this link also in the video's description. So in this repo, let's go to secret rotation folder. Under this, this is the command that we need to use to connect to database. I'm using a Docker command because if we don't use Docker command, in that case, I need to create a EC2 instance where I need to install MySQL client, configure it, and then only I'll be able to connect it. So rather than that, the easy way is we can use a Docker and where already MySQL client will be installed. We're going to provide host name, username, and password, and we will be able to connect to the database. So let's do that. To execute this Docker instruction also, I have a machine which is already ready, a test server. So these are the prerequisites also which are required. Database, one EC2 machine should be created, and as well as I've created two secrets. If you want to practice it with one secret, so then you can go with only one secret. So in my case, I want to enable automatic rotation for both the secrets. So that's the reason I've just taken two secrets. So now let me connect to this particular EC2 instance. And also let me log in as a sudo user. And in this particular instance, already Docker is installed. So now I'll directly execute this particular command. And here we need to provide the host name as well as username. So let's copy the host name from AWS console. So this is the endpoint. So let me take the right endpoint. And the default admin username is admin. So I'm gonna provide that as well. Password, I won't hard code it into this particular command. So when I execute this particular one, I'll be prompted to enter the password. So now I'm gonna enter the password, which is same as whatever the value that I've stored in my secret manager, which is admin123 hash. So let's retrieve the secret value. So the same password is being used for this particular database connectivity. And now, so once this is done, so let's create few databases. So which will gonna help as a testing when we rotate a new password, and we'll also connect with a new password and we will verify whether this data is there or not, or we are able to connect to the database or not. So for that, what I'll do is I've also provided those commands as well, database commands, to create a database and create a table and to insert the data, and the select command also to retrieve the data as well. So let me copy all the commands and put it over this particular EC2 instance. And now you can see that I've created a database, created table in the database, which is named Jira_data. And post which I've inserted data to a table which is called as Jira tickets. And now I'm executing select star from Jira tickets. So this is to get the data from the table. So now we have inserted the data, and with the current password, we are able to connect to the database. So now let me come out of this particular database. And the other secret where we have GitLab pack token, let's test that as well. So here I'm storing a pack token, which helps me to clone the GitLab repos and to execute some of the APIs related to GitLab. So let me also show you that. So this is the GitLab UI. And if you don't have GitLab login, so then you can easily register by using Gmail account, and it will ask you to enter few of the details, post which you'll be able to easily create the GitLab account. And in that, I've already created a repo. And once these things are done, so to create a pack token, we need to go to user preferences. And under user preferences, you will be able to see access tokens. So this is where we need to create a personal access token. You can click on add new, and then we can create it. In my case, I've already created one. So that particular value is stored in this particular secrets. So now what we will do is we will try to clone the repository from the GitLab, and we will going to use the pack token. And to clone, so I'm going to use HTTPS, because if I want to use pack token, so then I need to go with HTTPS clone URL, git clone, and then I'm going to provide the URL. So once I provide the URL, you can see that it is asking me to enter the username and then a password. I'm going to retrieve it from this particular secret. And this is a pack token. I'm going to provide it in EC2 instance. So once I do that, you can see that the repo is cloned. So even for this particular secret, we will gonna rotate it with the new pack token. We will again clone the same repository. So to check whether the newly created token is valid or not. So now we have tested the existing secrets. So we will gonna enable the Lambda function to rotate the secrets. So that is what we will gonna do it. For that, let me go into the secret manager. And first we will gonna automate the secret rotation for this DB admin password. Then later we will gonna consider this GitLab app token. So for this app admin password, so to enable a Lambda function to rotate the secret, we need to go to rotation tab and click on edit, enable automatic rotation. So I'm gonna give it as 25 days. For every 25 days, it has to trigger a Lambda function, which will rotate this particular secret. So as of now, you can see that there is no Lambda function in my case. So that's where I'm going to click on create function. So it will going to open a Lambda function page. So this is where we will going to create a Lambda function. Let me click on functions and then click on create function. So this is where I'm going to choose author from scratch. I'm going to provide the name as password rotation and then the runtime environment. I'm going to write the logic in Python 3.9. So I'm going to choose Python 3.9 and the architecture. This Lambda function will be kind of executed on compute resources. So that's the reason we need to select with what architecture the compute resource has to be created and upon which the logic that we give should be executed. In my case, x84 64-bit, that's fine. So I'm going to go with this. And then the next one is very important. We need to provide now the permission to Lambda function to use other services. For example, this Lambda function will gonna read the value from secret manager and it will gonna put the new secret. So that means it requires a permission to access this particular secret manager. And also in my logic, I'll have a part of a code which will connect to DB and execute some queries to check the newly created token is correct or not. For that, we need to provide the permission to the DB as well. So likewise, for few more services, we need to provide a permission for this particular Lambda function. So for that, that's the reason we need to provide a execution role. So I'm gonna select this use existing role and I'm gonna create one of the role by just clicking on IAML console here so that I'll be redirected to IAM page. And this is where I'm gonna create a role. So I'm gonna choose here AWS service, use cases, Lambda, and then click on next. Here we need to select few policies. So those policies also I have documented here in this particular readme.md. So the first one is Amazon RDS full access. Just to keep it simple, I'm just providing a RDS full access. But ideally in real-time projects, you need to reduce this particular permission to just to read or like to connect to RDS. To keep it simple as it is a demo, I'm just giving it as a full access. AWS Lambda VPC. So this is also required to run our Lambda function properly. I'll choose this one and as well as quickly I'm going to choose other two policies. CloudWatch full access. Every Lambda function stores its locks in the CloudWatch. So it requires access to pull and push the logs from the CloudWatch. And then last but not the least, which is secret manager read write. So this is very important because we need to read the values from the secret manager and update the new secrets as well. So that's the reason read write policy is required. Let me click on next. Provide a role name. I'm going to provide it as password rotation. And then you can give a description. If you want to change it, you can go ahead and you can change it. And this shows what are the permissions this role has. And let me click on create role. And it says that already this particular role exists. I will say password rotation secrets, any name that we can give, it should be meaningful. That's it. So I've provided it. Now this particular role has been created. Let's copy this name and then let me go to the Lambda page. Let's refresh it here. And now that particular role should be pop up here. So now I've selected that. So now by using this particular role, we are giving Lambda function a permission to access secret manager, database, and many other services as well. And additional configuration. So we'll come to this particular one in later point of time. So now with these settings, let me click on create function. And this is where we have multiple tabs. You can see you can write code here. And if you want to test this particular Lambda function, you can go to the test tab and you can initiate a test, monitoring how many invocations is happening on this particular Lambda function. We can check that particular one. If you want to change any configuration, for example, this Lambda function has a timeout of 3 seconds. If I want to change that particular one, so in the configuration tab, we need to change it. So let me change that. 3 seconds is not enough for me. So I'm gonna change the timeout for this Lambda is 1 minute or 1 minute 30 seconds I can give. And then let me click on save. Once this is done, so there are so many other permissions as well. So one very important thing is permissions. Here, this is a role that we have attached. So by using this role, Lambda function, for Lambda function, we are giving a permission, what are all the different services that it has to access. And the same way, if my secret manager has to access this particular Lambda function to invoke for our secret rotation, so then we need to add this resource-based policy statement as well. Let me click on add permissions, AWS service. This is where we need to choose secret manager. This is because we are doing this particular steps because if you don't do it, so then our secret manager won't be able to access this Lambda function. If our secret manager has to access this Lambda function, these steps we need to do it. Here, let me provide any statement ID, my secret manager ID, and then action should be invoke Lambda function. So I'm giving secret manager to invoke this Lambda function. So once we create this resource-based policy statement, then only in my secret manager, I would be able to select that particular Lambda function. Now you can see Lambda function has been selected. Let me save it. So now Lambda function has been created and it is also enabled for the secret rotation in the secret manager settings. You can see when we click now rotate secret immediately, then it will gonna trigger this particular Lambda function and it will gonna execute. Lambda function will be executed. Now let's write the logic in this particular Lambda function. So logic is based on Python code. The Python code is also already written. I've stored it in GitHub. So let's see that particular one. So this is the secret rotation.py. I'm going to use this particular Python code and I'm going to rotate the secret. So let me copy paste first and then I'm going to explain each block of the code in this particular Lambda function. So already there will be a default code. So let me remove that particular one, provide this particular Python code, and then let me click on deploy. Now let's have a look at the Lambda function code. So I've defined or importing whatever the Python modules that I require. And then when secret invokes this particular Lambda function to rotate the secret, logic will be started from here, which is Lambda underscore handler. And this particular method will be called and the secret will also send the information and it will be captured in the input variable event. And by capturing that particular input variable, you can see here I'm creating a few variables. I'm storing the event information like secret ARN, the version token. Token is nothing but the version ID of the secret. So let's say this is a secret and whatever the versions that we have, all that version information is also kind of sent to this particular Lambda function. And the Lambda function will be invoked 4 times by the secret to rotate one secret. And whenever it invokes, 4 times it invokes, the details will be same. ARN token will be same, but only the thing is the step value will be changed. Let me show you in my Excalibur. I've just wrote down that. So when my secret first it invokes, it'll call the Lambda function with the step value create secret. And in this particular step or in this particular invocation, what Lambda function should do is it should create a new password and update that particular new password to the secret with the new version ID. So whenever you update a value in secret, it will gonna create a new version and then only the value will be updated. And whichever the version as AWS current as a staging label, so that is what the value of the secret will be. So in my case, I have only one version. You can see that that particular version is set to current AWS current. So that's the reason that particular value will be same. So here also, whatever the secret that we would create, so that should be created as a new version and updated back to our secret. And once that is done, so the second time when it invokes, So now the step name will be set secret. In this particular step or in this particular invocation, whatever the newly created password is there, that particular password we should take. And if you want to set that particular password in any other place, let's assume in some repository or in some file or in any other services, that steps we need to do it. In our case, set secret is a very important stage because we are updating the database password. So it's not about only updating the secret value. We need to also update the secret in RDS. So I'm using MySQL RDS. Password has to be updated in this particular database as well. So that is what we will be doing it under this particular step or in this particular invocation. Once this is successful, secret will again invoke Lambda function, and now the step name will be test secret. And all these steps, you can write a logic or you can ignore it. It's up to us how we want to design the Lambda function. But in production level Lambda functions, it's better to split different activities. So depending on the steps, if we segregate the different updates and different parts of secret generation, then it would be really better. In this test secret step, so whatever the new password is there, so we will gonna test that particular password whether it is correct or not. In our case, we will gonna connect to database with the new password, and we will gonna check whether the connection is successful or not. So once this is test secret is done, so again secret manager or secret will invoke the final time it will gonna invoke, and now the step name will be finish secret. In this particular step or invocation, so we need to set the new version, whatever the new version that we will be created in the first invocation, right? That particular version, we need to change it as AWS current. So that if someone retrieves this particular secret, so that version's value will be taken and provided to them. So those are the things that we need to do it in our Lambda function. So now with this understanding, let's have a look into the code that we have. So let me clear this particular drawings. And I've created few variables where I'm storing the event information, post which I'm printing the step and token value. This is just for debugging. In production level projects or production level Lambda functions, we should not print much information. So this is just for a debugging purpose. And here I'm initiating the communication with secret manager by using Boto3. I'm creating a client connection to the secret manager. Now, if I use this variable, I'll have kind of communication with the secret manager. And once this is done, I'm creating one more variable, which is called as metadata. This is where by using a service client connection describe method, I'm getting the information about my secret. So in that particular information, I'm very much interested in rotation enabled or not. So here I am checking whether rotation is enabled or not. If rotation enabled, so then only I'll move ahead with further logic. If it is not, so then I'll raise an exception and I'll print this particular message. If rotation is enabled, that is where this logic will be implemented. As I said, 4 invocations will be there from the secret to this Lambda function. First invocation, when it sends, create secret will be the step value. So here I have a if else ladder. If step is equals to create secret, then it will gonna execute this method. For this method, I'm sending 3 input variables. One is service underscore client, which is a client connection to the secret manager, ARN, Amazon resource number of the secret, and the token, which is the version. All these 3 parameters is sent to this create secret method. And in this particular method, we should have a logic to create a new password, update it back to the secrets with a new version ID. So let's have a look into the code. Here I'm using try and except block. In try, first I'm getting the secret value from the secret by providing secret ARN and version and also version stage. So here in simple terms, if I want to say, I'm sending a query to secret to check is there any version with the staging labels as AWS pending. So that is what I'm trying to do with this particular line of a code. So once I check that particular one, If it is not found, if I don't have any version with a version label AWS pending, so then it comes to this part of a block, exception. In this exception block, so I'm creating a new password by again using a secret manager client, get random password. I'm creating a random password. I'm storing it in a variable. The next step would be again by using a client connection, put secret value with these input parameters, ARN, client token, secret string. So whatever the previous password, previous step password that we have created, that particular random password, we are sending it as a input variable for put secret and version stages as AWS pending. So when it executes this particular method, first it checks any version with the AWS pending is there or not. If it is there, fine. It goes or again it informs secret. So you this create secret is done. So you can send one more invocation with a step value is set secret. But if this particular AWS pending is not there, so then it comes to this exception block. This is where we are generating a random password and putting it back to the secret with a new version ID. When we execute this particular step, still the secret will have one version, a new version, but the staging label for that new version will be AWS pending. And post this particular first invocation, the value of the secret will be the previous value itself, admin 123. And once this particular step is executed successfully, then the second invocation will come into picture. Now the step name will be set as set secret. In this set secret step, so as I mentioned earlier, so we need to update this new password, whatever we have created in the create secret step, in any other places. If it is required in some configuration file or an S3 file, wherever it is, we should update it. In our case, as we are changing the database password, in the first step, we have created an only AWS secret manager and we placed it in one of the secret. But this password, we need to take it and also we need to update it in the database as well. So in the set secret, so in the set secret step, so that is what I'm trying to do. Second invocation step will be set secret, right? So you can see if step is equals to set secret, I'm calling this particular method. Again, for this method, I'm sending three inputs, service client, ARN, and token. Let's have a look into this particular method, what is exactly it is doing. So first I'm retrieving the value from the secret of the new password, whatever I would have updated back in the create secret. That value, I'm placing it in a variable and post which I'm defining few variables to have the database name and also to extract the only secret string from the details of my secret. I'm creating a variable, I'm storing it. And after that, I'm printing the database password. This is just for debugging. In production level, this is not suggested at all. In the logs, we should not print the DB password. Once this is done, so I have proper variables and once I have a proper data, I'm creating now RDS client by using Boto3. This is for updating the password in the database. So first I'm creating a client for RDS communication. So once the client is created, so then I'm using that particular client and modify DB cluster method I'm using. In that particular modify DB cluster, I'm setting few input variables like DB cluster name and also the password with which the database should be updated and apply immediately. We need to set it to true. So as soon as possible, it applies the new password. And once this is done, if it is successfully done, it will print in a logs a message saying that updated Aurora cluster DB password successfully. So this is a second invocation execution. So even this particular execution, if it is successful, so then it will invoke the third time. So in this third time, so it sets the step value as test secret. So in this particular Lambda function, again, it starts with Lambda handler and it sets all the variables and it will check rotation. Of course, it will be enabled. And now the step value will be test secret as this is a third invocation. So if it is test secret, you can see that I'm calling this method. In this particular method, I have a logic first to retrieve the new password that I've updated back in my secret. And then I'm creating a db underscore password variable. This is where I'm extracting only the secret string out of this pending secret variable. And then I'm creating a variable for storing host name, admin, Jira data. In this particular step, what I'm trying to do is I'm trying to connect to database by using a new password. So I'm preparing all the variables. After that, I'm running a for each loop here. As soon as the set secret is executed, DB will gonna take a little bit of time. So that's the reason I want to execute it for a multiple times to check the connectivity. So I'm running this for loop for the five times. And this is very important. This is where what I'm trying to do is by using py MySQL module, I'm trying to connect to the DB by using these variables. Host. So this is the host details, and then username, DB username, which is admin by default. This is also hard coded, and password, which is this. That value I've got it from executing this logic. So that new password will be kind of provided here, and database name. And the connection timeout I've specified as 5 seconds. Within 5 seconds, it has to be connected to the database. So if it is successful, so then it just prints password test is successful, able to connect to Aurora DB. If it is not, then it comes under exception block. Under exception block, I'm printing, this is attempt 1 in the first loop of execution. So if it fails, it comes to this particular block, it prints. So this is where you can see time module, I'm using it and I'm waiting for 10 seconds. After 10 seconds, again, the second loop will gonna start. Again, it initializes the connection. It'll gonna check the connection. It'll again, if it is passed, then it's fine. If it is fails, then it'll try for 5 times. If it is not successful even after 5 times, then it comes under this part of a code and it raises the error saying failed to authenticate Aurora DB with a new password after so many tries. This is what it will be printed. And here we can have a logic to kind of update back the password of the database with the previous password. We can have a logic. Just to keep it simple, I'm just printing this particular message. If it is a production password, so then we need to have a logic to update the database password to the previous value. So this is what we will be doing it in test secret. And once test secret method is also executed successfully. Now create secret, if it is executed successfully, then the second invocation comes in. So this is where we execute the set secret logic. If it is successful, so then test secret. Once test secret is done, so the final thing is finish secret. In this finish secret step, we need to set whatever the new version that we will be created in this secret, right? That we need to set as AWS current. Then only if someone retrieves this particular value, the new password will be provided to them. So here in this particular step, we will be removing that particular stage. In the first stage or in the first step, in the create secret, we will be creating a new version and we will be setting up that particular version with the AWS pending, right? In the finish secret, if set secret and test secret execute successfully, in the finish secret, we will gonna remove that AWS pending and we will gonna set the new version as AWS current label. So that is what we will be doing it in this finish secret. So let's see that finish secret would be very simple. You can see I'm reading the version stages and I'm setting the version stage for a new version, right? I'm setting the version stage or a label as AWS current. So when we set this, now if somebody accesses this particular secret, the new password will be provided to them. So this is the logic behind this particular Lambda function. 4 invocations will be there from the secret to rotate one secret. And it will gonna send different step for each invocation. And according to the step, we are taking actions. First step, we are creating a new password, updating back to the secret with a new version and setting that new version with a AWS pending staging label. And then in the set secret, we are updating that newly created password in database. And once that is successful, so then test secret invocation will be executed. This is where we're testing by taking a new password whether we are able to connect to DB or not. If this is also successful, so then we come to finish secret step. So we're going to remove AWS pending staging label. We will attach AWS current label so that the value of that particular secret will be set to the new password. So now let's execute this particular logic in the Lambda function. Before executing a Lambda function, so we need to do few changes here because database values and database cluster ID, all those kind of things, we need to change it. So first thing is DB cluster ID. Let me remove this database one and I'm going to provide my database ID is app_db. Let me update the same. Once this is done, so in the test secret, so we need to provide DB host. Again, I'll go to database page. I'm going to copy this particular one and we're going to provide it in the Lambda function. And the admin user will be admin itself. So DB name, if you remember in the beginning to test the current passwords, we created Jira underscore data database. So the same database name I'm referring it here. So other than that, we don't need to change anything else. So let me now click on deploy so that the new changes will be deployed in Lambda function. So Lambda function is successfully updated. Let's go to the secret and here secret rotation. So let me refresh it. You can see that secret rotation is enabled. For every 25 days, it will going to call this particular Lambda function and the secrets will be rotated. But in my case, I can't wait for 25 days. So that's the reason I'm going to click on rotate secret immediately. Let's do that. Rotate. And when I do that, so you can see that failed to rotate the secret. There are previous rotation isn't complete. So let's check. I mean, this is a message because this is a free account that I'm using. So if there is any already other Lambda function invocations, if it is running, so this is the error message that I'm gonna get. But let's look into the Lambda function monitoring tab. So we'll get more information. So let me go to monitor and we can click on CloudWatch logs actually. So when we can click on CloudWatch logs. So this is where we can see the logs related to this password rotation. And I see that so it has been executed recently. And let's see the logs. What are the logs of this particular one? And I see the execution has failed. It says that import module error. So no module named py MySQL. So Lambda function will have whatever the generic Python modules are there, right? So it'll have information about that. So especially py MySQL, this is a custom module that I've used, which is not regularly used. So it doesn't have libraries or files which are required for importing this py MySQL. So that's the reason we need to provide py MySQL library files manually for the Lambda function. So there are two ways. So one is in the code itself, the code and also library files of MySQL. So we can combine together, create a zip file and upload it here. So that is one way. The other way is we can create something called as layers. So those libraries, we can zip it and we can add a Lambda layer, and that particular layer, we can add it to this particular Lambda function. So I would always suggest to go with the layers because if you create one layer, it can be used across multiple Lambda functions. So to do that, so first we need to go to layers tab. I see that I have few already, but anyway, so we will gonna create a new layer. So to do that, I have a commands or instructions provided in this readme.md of this particular repository. So let me look into that. So these are the two commands that I need to execute it. Now what it does is it will do pip install py_mysql and it will gonna store the files, whatever it download in Python folder. So after that, I'm executing a zip command to zip this particular Python folder. The name of the zip file will be lambda layer. Let's execute this. I'll execute this in my Windows machine, Visual Studio Code. So first is pip install. So all these files now will be stored in Python folder. And also the second command was using a zip command. So that zip command will convert this Python folder into a zip file. the name of the zip file will be Lambda layer. So now this Lambda layer is created, right? So the same Lambda layer, we need to import it in the Lambda page. So first is you need to go into layer, create a layer. And we can give a description that is optional, but however, I'm going to copy the name and I'll provide it in the description. And now I want to upload a zip. So I'm going to go to the same location where I've created it. It is under DevOps Git practice. And under that, so I have created a Lambda layer. This is a file. So I'm going to import this and then I need to choose architectures. In my case, Lambda function is running with architecture x86 64-bit. So I'm choosing that. Compatible runtimes. I'm using Python 3.9. So I'm going to choose the same. And then license information. If you want to give anything, you can provide it. In my case, nothing. I'm going to click on create. And it will going to create a layer for me. So once the layer is created, so we need to go to Lambda functions, go to the Lambda function, and this is where we need to choose a layer. So layers, click on the layers. Here, add a layer. And once I click on add layer, so custom layers. These are AWS maintained layers. In my case, I need to go with custom layer. So I'm going to choose password rotation py MySQL. And once that is done, we need to choose version also, what version of a layer that we need to select. So now let me click on add. So once these things are done, so we can again invoke this particular Lambda function from secret by clicking on rotate secret immediately. So we can also check is the Lambda functions are still running or not by just looking at the CloudWatch logs. We can go to password rotation, click on start tailing. So when we tail it, so if currently if any events are running in this particular Lambda function, so it will be printed here. So I don't see anything. So what we will do is now again click on rotate secret immediately. But before that, I want to do one more setting in the Lambda function. So in the configurations, in asynchronous invocation, I want to change this retry attempts as 0. I don't want to retry this Lambda function in case of failure. So now let's go to the secret again. Let's click on rotate secret immediately and rotate. So now, so let's see in the CloudWatch tail. So if something is, so I can see here some logs are being printed here. So the first one is create secret. So if you remember or not, in our Lambda function, we are printing step name and also version. We can see that create secret step is executed. The first invocation is successful. Set secret is called, and it is setting the Aurora cluster appdb master password. This is also successful, and we are printing the password as well. Set secret, it is executed successfully. And the next one is test secret. So we have a for loop. For 4 times it has failed. It says that can't connect to MySQL server, which is timed out. And this is expected as well, because if you look at our Lambda function, so we are not running in a VPC. So whatever the compute resources which will be used by Lambda function, which is outside our VPC. So that's the reason we are getting unable to connect. So to solve this particular problem, so we need to create a private subnet within our VPC. And then we need to make sure that Lambda function is running on the compute resources which is created inside that VPC. This is because if you look at my database, here this particular database is not publicly accessible. This is only accessible within VPC itself. So that's the reason I need to create a private subnet. And then within that private subnet, I need to launch Lambda function, and through which I'll be able to access this particular database. So if we don't do that, so these are the errors that we might end up with. So you can see that 5 times the database connection has been tried, and all the 5 times it has failed to connect. So let's try that particular settings. So first and foremost thing is I need to create a private subnet. So to do that, let's go into VPC page. For a private subnet, we need to have NAT gateway. If it wants to connect or like it has to have an internet connectivity, the NAT gateway should be there. So first let's create a NAT gateway. Create NAT gateway and provide a name. So I will give it as Lambda NAT gateway. And we need to choose a subnet. So we need to choose any public subnet. So I'm going to choose 1A as a public subnet. And then we need to allocate elastic IP. So let me do that as well. So once that is done, so let's create a NAT gateway. So without this, I won't be able to communicate with my database. So that's the reason I'm creating this NAT gateway and associating this particular NAT gateway with my private subnet. And that private subnet, I'll be using it in my Lambda function. So then Lambda function will be able to connect to the database. This is because we have a test step. So by using test step, we are connecting to DB and we are verifying the new password, which is created as proper or not. So for that reason, we are creating all these networking components as well. So let's create a private subnet. Create subnet, choose a VPC. Let's give a subnet name, my Lambda private subnet. So availability zone preference, I will gonna go with US 1A and CIDR range, a range of IP addresses which is not conflicting with other subnets. Let me look into all the other subnets. What is the IP range there it is used? So I see 6480. So I'm gonna take this value and I'm gonna provide instead of 196, let me provide it as 120. So different IP range should not be conflicting with any other subnets. We should provide that value. So let me create this subnet in the VPC. Once the subnet is created, we need to associate that subnet with a route table. So I see that already there is a route table which is associated with it. So edit route table, or we can directly go to the route table which is associated. I think this is a route table that it has associated with. So let's create another route table. So I'm going to call this as my Lambda private route table. Select VPC and create route table. And it should be associated with my Lambda private subnet. Save the association. And here we need to edit the routes, add NAT gateway. So we need to select NAT gateway. And then whatever the NAT gateway that we have created, we need to select this particular one. Now let's go to subnets and let's see what are all the routes which are associated with it. I see that only my Lambda private route table is associated with it and which has a NAT gateway connectivity. Subnet is created. Now let's go to Lambda function. In this, we need to click on edit in a VPC section and then choose a VPC. We have only one default VPC. I'm choosing that. So subnets 1A I'm gonna choose. This is a subnet that I'm gonna choose, which I had created. And then there is a warning. So at least we need to select two subnets, but I'm fine with one subnet now. And then the security groups. So I've used default. So while creating a database, the same security group I'm gonna use it. And let me click on save. So once we do this VPC change, now for executing Lambda function, AWS will gonna create compute resources within this particular VPC. And that particular compute will be able to kind of connect with the database and we will be able to see that test step will be succeeded. So let's wait for this updating of the Lambda function. Once it is successful, so then again we can do a secret rotation. So meanwhile, while it is updating, I'll go to CloudWatch. I'll clear this particular logs. So it's a so it took a lot of time to update this particular configuration. Now let me go to the secret manager again and let's click on rotate secret immediately. Rotate and let's look at the CloudWatch logs. So here now let's look at the create secret invocation successful, set secret is successful. It has updated the database password and then test secret. So in the first go itself, it says that password test is succeeded, able to connect to Aurora database, and then finalizing or finishing the secret rotation. That means now we have a new password which is completely rotated properly. So let's go to the secret and let's look at the value of the secret now. Retrieve secret value. Previously it was admin123. Now you can see that this is a password which has been updated in the database. So in the Lambda function also we have tested it. Manually also we will going to test with this particular password. So let me log into EC2. So this is where I've already logged in. So let's execute this Docker instruction through which we will be able to connect to the DB. And now the password that I'm going to use will be this. I'm able to connect with a new password. Let's execute select star from Jira tickets. So we need to use this semicolon as well. So I think the database name is not correct. Oh, first we need to connect to the database. Let me go to this particular readme.md and this is where first we need to use this Jira data. And once this is done, so we're gonna use select command to look at the data. So now I'm able to see the data of Jira tickets as well. So whatever the new password which has been created, which is correct, working as expected. And even the versions you can see. So whatever the previous version was there, it is set to AWS previous. And the new version, which is set to AWS current. I'm not sure why this AWS pending is not removed. It should be removed. So now let's again click on rotate. So now let's see what it will do. So let me click on rotate secret immediately. It should create a new secret now again. Let's monitor the CloudWatch logs. Let me clear it. And let's wait for a new logs. So it should again invoke create secret, set secret. So new password it has set. And then in the test secret, the first attempt has been failed, which says access denied. After 10 seconds of pause, so again, I'm gonna connect back to the database. So let's see what will happen. So after that 10 minutes, again, database connection code has been executed. You can see that password test is succeeded. Post was the finishing secrets. That means the new password version is set as AWS current. So let's have a look into that. So let's go to AWS Secret Manager and let's look at versions. Now I have two versions. This was previous, this is the current one. And let's check now the secret value, which is completely different. And you can see now the password has been rotated successfully within few seconds and it is automated as well. No human intervention is required. Here, I can't wait for 25 days. That's the reason I was clicking on rotate secret immediately. But if for every 25 days, it will be calling this particular Lambda function. So then this Lambda function is responsible for rotating the new password and setting the password in the Lambda function as well. We have successfully enabled automatic rotation for database password. So now we have the other secret, which is GitLab paired token. For this also, we need to implement automatic rotation. So now if you want to implement automatic rotation for GitLab paired token, it will be completely different logic. So here we will have two options. One option is creating a separate Lambda function. Use that particular Lambda function to rotate this pad token. Or we should somehow reuse the same Lambda function and then use the Lambda function for rotating password and pad token as well. So I would go with the second option because if you go with the first option, consider real-time project where we will have lot many other secrets, tokens, passwords related to different tools. If we go one token or one secret, one Lambda function, we end up managing so many Lambda functions, which is not correct. We should have one Lambda function for one purpose. So that is a concept. We'll also take it here. So we will going to use the same Lambda function to rotate both database password as well as GitLab pad token. So to do that, one thing I need to do, first and foremost thing is I need to tag each secret with the tool name. So let me do that. Let me go to tag section. So here I'm gonna add a tag tool and I'm gonna provide the value as database. I'll do the same thing for GitLab pad token as well. So I'm gonna go here and add a tag tool GitLab. Now what I can do in my Lambda function. So once Lambda function is triggered, first and foremost thing is I need to read the value of this tag tool value. So if it is GitLab, so then I need to execute certain logic. If the tag is database, then whatever the logic that we have implemented, that has to be executed. So for that also, code I've written and placed it in the GitHub repository. So for that, so we need to use multi-tool py. So this is the Python code that I need to use. Here you can see that I'm importing all the required Python modules. And my secret, whenever it invokes a Lambda function, this is where the execution will gonna start. All the variables which I have explained in previous Python file, which is same, I'm storing secret ARN, token, step in a variables. And I'm initiating a client so that I can communicate with secret manager service to get, to update, and to do execute the operations related to secret manager. And the next step is important. This is where I'm trying to describe the secret and storing the tag values in tags variable. Post that, I'm creating one more variable. This is where I'm reading the tool tag value. So if the Lambda function is triggered from this particular secret, then the value of this tool will be database. If the Lambda function is triggered from GitLab pad token, then the value of tool will be GitLab. So by using this particular logic or a block of a code, so I'm extracting the value of that tool tag. So if tool tag is not present, so then I'm just printing this message and I'm exiting out of this particular Lambda function. If tool tag is there, so then you can look at here, it will go and execute further logic. So here also again metadata, I'm using metadata, checking rotation is enabled or not. The same logic that we had used for rotating database password. If it is enabled, rotation is enabled, it comes to this part. So as we already know, Lambda function will be invoked by AWS secret multiple times with a different step values. First invocation will be create secret. When it is create, so it is calling create underscore secret. So this is where when it comes to this particular method, if you could check here, so I'm checking if tool is equals to GitLab. That means if the Lambda function is called from GitLab pad token, so then the tool value will be GitLab. So here I'm also checking tool is equals to GitLab or not. If it is a GitLab, so then it comes to this part of a logic. So here I'm first printing this message, post which I'm executing this try block. Here what I'm trying to do is, so I'm trying to read the current password and I'm printing it. This is just for debugging. As I said, all these debugging statements, once it's done, should be removed. And post which I'm executing some API. So request.api. So to just check whether GitLab is reachable or not from the Lambda function. And after which I'm creating a variable where I'm establishing a connection with GitLab. So I'm using a GitLab module dot GitLab method. This is where I'm providing GitLab details, URL, and also current pad token. So this will authenticate my GitLab and provide a connection. So by using this connection, I'm establishing a connection to my personal access token. I'm getting all the personal access token. And then with token underscore object, with the connection to the pad tokens, I'm using a method which is called as rotate. This is responsible for rotating my pack token. And then once that is done, so I'm storing a new pack token in this variable and I'm printing it. Again, this is for debugging only. In production level Lambda functions, we should not do this. So once I get a new pack token, I'm updating back that to secret by setting the new version. When I update new password, it will be a new version. That new version will be set to AWS pending. By using this method, that is what I'm trying to do. This rotation fails, then I'm printing this message, password test failed. So this should have been password rotation failed. So this is the wrong message. Maybe we can correct it while we run the Lambda function. And in the same create underscore secret method, we have tool is equals to database. It executes this particular logic. So likewise in set secret, test secret, finish secret, we have a if condition. If database, then it executes this. If it is GitLab, so then it executes the other part. So that is how I've defined in my Lambda function. Of course, this Python code, we can make it little better. Just to keep it simple, I've used a simple if else conditions. And now once, for example, the Lambda function is triggered from GitLab pack token, right? So the create secret will be executed successfully. This part, let's say this part will be executed. And then the next invocation will be set secret. So again, it executes all these things. And now again, tool will be GitLab. Now the step value will be set secret. It comes to this part. And here, if it is database, then it executes this. You can see in my logic, if it is not database, it comes to this particular part and it just prints. So in the set secret for GitLab pack token, no action. I'm just printing this on the logs. Same way, the third invocation, this will be anyway successful in the second invocation because I'm not executing anything. I'm just printing on the logs. And in the third invocation, it will gonna call this test secret method. And this is where you can see again, if it is database, then I have a logic. If it is not a database, then I don't have any logic to execute. I'm just again printing. No action in testing a GitLab pack token secret. So just storing the new token. If you have some testing strategy, then we can write the logic for that. So in the finish secret, it is the same logic for both database or GitLab pack token. It will be one and the same because here we are reading all the stages and the new password, whatever we created it, we are updating that particular secret version stage or a label to AWS current. And we will gonna remove AWS pending. So that is what we are trying to do. I've copied the code from this multitool.py to the Lambda function. You can see here now we are reading a tag value, placing it in tools variable, and post which, depending on the tool, we are running different logic for rotating the secret. Here we need to update this particular print statement, password rotation failed or token rotation failed. And then in the database logic also, in the set secret, we need to update this cluster ID. In my case, the cluster ID is app.db. And in test secret, we need to change this DB host. So let me update that particular value. And DB user is admin, DB name is Jira data. That should be fine. Yeah, rest everything would be the same. Let me click on deploy. In the secret GitLab pack token, we didn't enable that secret rotation option. So let's enable that particular one. Automatic rotation, enable. We need to select a rotation schedule. I'm going to go with schedule expression builder. That means on regular intervals, every 25 days, I want to execute or invoke this password rotation Lambda function. So let's save. And now in the CloudWatch, so let me clear all the logs. I'm going to close the subnet windows. I'm going to clear or again, I'm going to start tailing that particular CloudWatch logs. Left click on password rotation, start tailing. Let me go to GitLab pack token. Let me click on rotate secret immediately. So let's have a look into this particular logs, rotating the secret. So I didn't see any logs. It's going to take a little bit of time to launch compute resources for the Lambda function and then trigger the Lambda logic. So here you can see that it fails. I see that it says that no module of type GitLab. So it fails with this particular error message. So this is already known. We have seen the similar issue when we rotated the secret of the database where it failed with py MySQL module not found. So now let's add this module also as a layer. So to do that, I have already provided instructions in this particular repository. So let's follow that. So this is the instructions to create a layer.zip file for GitLab. So let's do that. Let me go here. Let me clear the screen and paste all the commands. So it creates first a Lambda layer folder. Under that, it is downloading all the libraries which are required for GitLab module. And then it is storing it in Python folder. And post which, so I'm executing a zip-r and the zip file name and also the folder where I have all the libraries related to GitLab module. So now when I press an enter, it fails. So let's see, there is a mistake in my command might be. We need to come back cd dot dot. So let me do ls. Now we need to execute that zip command. So now you can see that. So that particular zip file will be created. So now let me go to the Lambda function and layers. We can add multiple layers to the Lambda function. So we have already added one layer for py MySQL. Now let's create one more layer with the name password rotation. This time the module will be GitLab. And let me upload the zip file. So now in this particular case, it will be there in Lambda layer and then layer.zip. So this is the file that I need to upload it. Suppose that we need to choose the architecture and also compatible runtimes in my case, which is Python 3.9. So once this is done, so let's click on create. Once the layer is created, we can add that particular layer into our Lambda function. Let me go into Lambda, click on layers, and this page we will be in and add layer. So we need to choose again custom layer. This time password rotation GitLab version is 1 and then add. Now for both Python modules like PySQL and as well as GitLab module, we have added the layers. And the advantage with layers is these layers can be used for any other Lambda functions as well. So that is one advantage with these layers. And now again, let's go back to the secret. Before that, let me go to the CloudWatch logs and let's clear this particular logs. And again, I'll go to this particular secret. So let's click on rotate secret immediately. So once we do that, so let's go back to CloudWatch logs and let's monitor invocation of that Lambda function. So now you can see that here, the first thing is when Lambda is triggered from GitLab pad token. So in our logs, first it shows up the tool tag found. It is GitLab and it is creating a new pad token. The current pad token is this and the new pad token is this one. And post which for further steps, set secret and create secret, there is no action. So that's the reason we are just printing no action for setting GitLab pad token, just storing the new token. Likewise, in the test step also, we don't have any action. So it says no action in testing GitLab pad token, just storing it and then finishing the secret. This is common for both GitLab and database. Let me check now the versions of this particular secret. So now we can see there are two. So this is the previous one. This is the current one. So let's go and retrieve the value as well. So which is a new pad token. So let's test this particular new pad token. I'll go to my EC2. Let me reconnect to this particular EC2 instance. Let me log in as a sudo user, and we will gonna execute git clone again. And now we will gonna clone this particular repository to the different folder. New password is a folder. So under this particular folder, I'll gonna clone it. So it'll gonna prompt to enter username. So let me provide that. And then the new pad token. Whatever the new pad token that we have created, we need to use the same. So let me provide this pad token. And now you can see that it is successfully kind of cloned. And now let's test it with the database password. Let me go to the secrets, app, db, admin password. So let's retrieve. This is the current password, which ends with vivo. Let's click on rotate, and now post rotation, we will gonna see what will be the password. And in the logs also, we can monitor that. So let me clear, and let's wait for the new logs of new invocation of the Lambda function. You can see tool tag found, database. This is a new password. I'm updating a Aurora cluster DB password, and it says access denied for the first run. So now it waits for 10 seconds, and then it basically executes again, and it executes again the code to connect to DB. But here I see one error. It says that name time is not found. So this issue is in the Lambda function, we didn't define time module. So let's import time, and then let us deploy this particular Lambda function. So now the new code has been deployed successfully. Let me go to the CloudWatch, clear the logs again. Let me go to this particular DB password again, rotate secret immediately. When we do this, it'll invoke Lambda function, and we will be able to see the logs here. And here in the logs, you can see the tool is database. It is creating a new password, updating a new password for the database, and then testing the password. Password test succeeded, able to connect to Aurora database, and then in the end, finishing the secret rotation by updating the tags of a version in the secret. So now you can see that the single Lambda function we have used for rotating multiple secrets. And if we use this particular concept, it is easy to manage because we'll have one Lambda function which is used for rotating multiple secrets. So that's all for this particular video. If you have liked the video, please do like, share, and subscribe. Thank you. Have a good day.